Hello class, welcome to another lesson. Today's learning goals are I can reflect an image over the x and y axis and know how to identify the image's coordinates when given a pre-image's coordinates. It's also I can draw horizontal and vertical lines when given an equation, explain why the line represents the equation, and also I can reflect an image over any vertical or horizontal line. So let's go ahead and get started. So transformations, remember that there are 4 different kinds of transformations: translations, reflections, rotations, and dilations. Congruent means that the image maintains the same angles and the same lengths, while similar only maintains the same angles and has proportional sides to the pre-image. So translations, because they do not change the lengths of the sides and keeps the same image, they are congruent. Reflections also are congruent, and rotations are congruent, and dilations, because they change the lengths of the sides in a proportional way, maintain the same shape, but just bigger or smaller. This one is similar. If you do not recall these definitions, I highly recommend going back and reviewing these because these are incredibly important going forward. Reflections are the transformation that we're going to work with today. In transformations, the reflection transformation is where every point on the image is the same distance from the central line and the image is reflected over the line. And as we just said, that reflections produce congruent images. This is probably the most commonly used transformation because it's, for example, in facial symmetry, we have, reflection down the center. In art and design, things tend to be very symmetric. For example, leaves, animals like butterflies, and in digital animation, it's very common as well. So Pixar, things like that, where they have to create symmetric images. So the first one here says, given the following figure, reflect across the x-axis. Okay, so we have this point E right here, where it's -1, -2. To reflect it across the x-axis, you have to multiply every single one of the y-coordinates for each point by -1. And the reason that it's the y-coordinate is because when you reflect across the x-axis, you change the height of the image, right? It goes from this bottom 3 quadrant to the 2 quadrant right up here. And so you're changing the height, so therefore it's the y values that change. Okay, so from here, this E becomes E colon right here, and you can see that it becomes reflected over here. So we'll start off as -1, -2. What that becomes, the coordinates are -1, 2, and the images, because they have the same lengths and the same angles, even though they're in a different rotation, they are considered to be congruent. Okay. Over here it says, given the following figure, reflect the image across the y-axis. So we're reflecting it across this right here, which means that we are changing the direction left to right. So from the right side to the left side. So we're going to multiply the x-coordinates, because the x-coordinates determines the left and right part of the location. We're going to multiply each one of those by -1. So it should look something like this. Notice how it flips over. The y is over here, the y is over here, x, x, w, w. And the coordinate of w image is going to be 0. That should be -3. 0, -3. We have to fix that. And notice how that is still the same coordinate as w, regular w. Okay, that's because if you multiply the x-coordinate by -1, you still get 0, because 0 times anything is still 0. And again, this is going to be congruent because all we did was a reflection. The next thing we're going to do is talk about, we're going to go do this one first, drawing vertical and horizontal lines. So the first one says, draw y equals 5. Okay. Now, to draw y equals 5, you need to know some points that have a y-coordinate of 5. Okay. So I'm going to do 0, 5, because that has a y-coordinate of 5, so I'm going to put a dot right here. 2, 5, 4, 5. And let's even go towards the negative side a little bit. Negative 3, 5 is right here. Negative 5, 5 is right here. So these all make a, if I were to draw a line through all the dots, it would make a horizontal line. And that's exactly what y equals 5 is. It is a horizontal line where every single point on that line has a y coordinate of 5. Okay. So again, the reason that this is a horizontal line, y equals 5 is a horizontal line, is because every point on it has a y coordinate of 5. Conversely, for x negative 3, x equals negative 3, we're going to look for points that have x coordinate of negative 3. Okay. So it's going to include negative 3, 0, negative 3, 1, negative 3, 2, negative 3, 3, and let's go backwards, negative 3, negative 3, negative 3, negative 5. Okay. All of these have an x coordinate of negative 3, and that's what it is. It's a vertical line. X equals negative 3 is a vertical line because every point on this line has an x coordinate of negative 3, and that is why it is a vertical line. Okay. So try these two on your own. Okay. Draw y equals negative 2 and x equals 4, and then the next example is draw x equals negative 3 and y equals 1. In example number 5, y equals negative 2, so we're going to find all the points that have a y of negative 2, and that would be all right here, because so negative 4, negative 2, negative 2, negative 2, 1, negative 2, all of those. So our line for y equals negative 2 is this horizontal line right here. X equals 4, that'd be all the points on this line right here, so therefore it looks like that. Okay. For this one, x equals negative 3. Okay. Again, that's going to be all the points on here because all of these points right here have an x coordinate of negative 3. And then y equals 1 is going to be a horizontal line right here because all these points, 1, 1, 2, 1, 3, 1, 4, 1, all of those have a y coordinate of 1. Okay. Now, it says, given the following figure, reflect the image across the line y equals 1. Going back to the definition of what a transformation is transformation reflection is it's a transformation where every point on the image is the same distance from the central line, and the image is reflected over the line. So, if we're going to go back over to here, okay, y equals 1, we first need to start drawing y equals 1. And y equals 1 is going to be a horizontal line right here, if it will let me. Nope, it won't. So let's just draw that. Y equals 1. That's going to be a line right here. Okay? And then we need to make sure that every single one of these points, so M, the reflection of M, is going to be, again, 2 units away from this line. And it's going to be 2 units away on the opposite direction. Okay? So the M is going to be somewhere right here. N is going to be, again, 1 unit away from the central line, and it's going to be on the opposite side of the line, so it's going to be right here. So this is N, this is M. L, 1 unit away, so the image L is going to be right here. K, the image K is going to be 3 units away, so it's going to be up here. So the image should look something like this. Okay. The K image is going to be coordinates of negative 3. I believe that's 1, 2, 3, 4. Oh, no. Let's change that again. Negative 3, 4. Okay. Here we're going to reflect across the image across x equals negative 2. Again, we need to figure out what that looks like. So x equals negative 2, that's going to be a vertical line right here because every single point on this line has an x coordinate of negative 2, which means that s has to be 2 units away on the opposite side, so s should be right here. R should be therefore right here because it's 3 units away and so forth. So it should look something like that. And then the image of R has a coordinate of, let's see, 1, negative 4. And again, both of these, because they are the exact same image, just in a different angle, they are both going to produce congruent images, because reflections always produce congruent images. They don't change the lengths and they don't change the angles. Here we have to write a rule for this. Okay. So clearly this is being reflected across the y-axis right here. So how we write that is r with the sub notation of y-axis, comma xy, because this is being reflected across the x-axis. Here we can see that this is being reflected across the y equals 2 line right here. What we write is r equals y, r sub y equals 2 xy. That's called, that's the reflection notation. You can also just say reflects across the y equals 2. Okay. Over here, it says describe the rule for the transformation below. So if we go from, we have these points right here. So go ahead and graph this figure right here, this pre-image, and then graph this image and see what happens. So H is 1, 1, so that should be right here. 0, 2 right here. 3, 5 right here, and 5, 3. So that should get us something that looks like this right here. And if you graph the image or post image, then we should get 0, 2. So still right here, we get something like this. So as we can see, this is a reflection across the y-axis, which means that we're multiplying each one of these x-coordinates. So this 3 becomes a negative 3, this 5 becomes a negative 5, etc. So we have a rule of reflection across the y-axis. Then over here, go ahead and graph this one, and then graph this one, see what transformation, what kind of reflection occurs. So the first pre-image starts at 3, negative 5, so it's down here. And so our image looks like this, and then our post image or image is 3, negative 1. So that should be right here. As you guys can see, this is a reflection across the y equals negative 2. So our reflection is y equals negative 2. So what we're going to do is combine translation and reflections. Okay, so we can do multiple transformations at a time. So given the following quadrilateral STUV, apply the transformation below. So reflected across the y-axis, then translate 1 unit right and 2 units up. So that means that we're going to reflect across here. It means we're multiplying each one of the x-coordinates by negative 1. Okay. So go ahead and then we're going to translate that image, so the image that appears over here, to the right one and up 2. So right 1, up 2. Go ahead and try that out on your own. So this U should turn into something over here, and so right here is our reflected image across the y-axis. Then we're going to move each one of these to the right 1 and up 2. So this U point should end up being right here, which we can see it is. Okay. And as you can see, that if I were to cut this out, I could put it on top of here in such a way that they were directly overlapping. So that means they are congruent. And then V, image V, vertex, is going to be at 1, 2, 3, negative 3, negative 1. Right there. The final example we have here is a transformation and reflection. Okay. Translations and reflections. Okay. So given the following series of images, describe the transformation that this shape endured. You can do multiple reflections, or you can do a translation and reflection for this. There are multiple ways for doing this. Go ahead and see if you can figure out both ways to get this post image right here. One way you can think about this is that this is a slide, okay, or translation to over here, and then you can reflect this across the middle, which would be theoretically the x-axis, and get this post image. Another way you can think about this is this being flipped. Okay, across the y-axis, and then again across the x-axis, making 2 reflections. So you can think of it one of 2 different ways if it would show up. But apparently it is being fickle with me. So there we go. So you can it can be a slide to the right, a reflection across the x-axis, or you can also think about it as a reflection across, a reflection across the x-axis, then a reflection across the, reflection across the y, and then a reflection across the x-axis. I want to go back to our learning goals real quick. The first one, it says I can reflect an image across the x and y axis and know how to identify the image's coordinates when given a pre-image coordinates. Okay, so if you are given, you know how to flip something across the x and y axis if you are given the coordinates for points on the pre-image. Okay. Again, this deals with if you're flipping across the x-axis, you're going to multiply the y coordinates by -1, and if you're flipping across the the y-axis, you're going to multiply the x coordinates by -1. I can draw horizontal and vertical lines given an equation and explain why the line represents the equation. You should be able to explain why x equals 1 is a vertical line and why y equals 4 is a horizontal line. It's because each point on that line has a coordinate of either, for the first one, an x coordinate of 1, or in the second case, y coordinate of 4. And I can reflect an image over any vertical and horizontal line. Okay. So if you feel comfortable with all 3 of these, go ahead and try out the practice.